All right, we're going to work with negative and fractional exponents here. So let's take this first one. Let me maybe zoom in a little more for you. Okay. As you can see, we got a fraction for an exponent. What we want to do is take this 64 and rewrite it so it has an exponent of 3. That way, this 3 right there will cancel out. What do I mean by that? Well, 64 can be written, what's going on there? Can be written as 4 to the third because 4 times 4 times 4 is 64. So instead of putting 64, I just rewrote it like that. They're the same value. And as you can see, now if I raise that to the 2/3, what's going to happen? These 3's will cancel, so I'm left with 4 squared. Now, let's go back. You remember when you raise to a power, you multiply exponents. So I took 2/3 times 3. The 3's cancel. 4 squared is 16, and that's how that bad boy's done. Okay, let's do the same thing over here with 25. How can I rewrite 25? 5 squared. That one's pretty easy. Let's raise that to the 3 halves again. When I raise to a power, I multiply exponents. So these 2's will cancel, so I'm left with 5 to the third, and then 5 times 5 is 25, times 5 is 125. You can get a calculator, bingo. Down here, we don't want negative exponents or anything like that. So what is this? I don't care what's in there. As soon as you raise it to the 0 power, you could have any number in the world in there. You could have a cup of coffee in there. It doesn't matter. Anything to the 0 power is 1, so that's my answer. B, all right, 16 to the 1/2. Again, once you get some experience, you'll know 1/2 means square root. Square root of 16 is 4, but let me show you again. 4 squared. You see how I wrote 16 as 4 squared? 4 times 4 is 16. Raised to the 1/2. Okay, and then we still have, let me just rewrite everything. No big deal. Take some baby steps. That's a negative sign right there. Okay, well, when I raise to a power, that cancels, so I'm just left with 4x to the 4th times 3x to the negative 5. Okay, what is 4 times 3? 12. And since I have the same base x, I write down the base. And then when you multiply, you add exponents. So what is 4 take away 5? Negative 1. But that's not going to cut it because we don't want negative exponents. So what you want to do is think of it this way. This 12 has an exponent of what? There's really an imaginary 1 there. Oh, that's terrible. Let me get rid of that. There's really an imaginary 1. Okay, so the 12 hasn't been negative. So the 12 is going to stay put. This x has been negative because it's got a negative exponent. So since it's upstairs, it's got to be moved downstairs until it's positive. And really, no, see that 1 there? You could put that. It's kind of tacky. Nobody does it. So let's erase it. And there's my answer. Okay, let's slide over for this last one. All right, let's use that same logic. What exponent is with this 6? It's really an invisible, let me make it red. It's really an invisible 1. So that 6 has a positive exponent, so that stays put. This m has been negative, so that's got to get moved downstairs until it straightens out its act and becomes positive. And there's my answer. Take a